Welcome to The Explainer. Today, we're tackling an equation that honestly started out as a bit of a joke, a conceptual toy, but it ended up revealing something absolutely profound about reality itself. Yeah, this is a story about seeing the unseeable, measuring the unmeasurable, and believe it or not, finding ourselves hidden right there in the math.
All right, so let's just jump right in with the central tension here, right from the get-go. I mean, for the experts who first laid eyes on this thing, it was walking a razor's edge. Was it a revolutionary breakthrough, or was it just, complete nonsense? A bunch of symbols just slapped together.
So first things first, let's actually look at the equation itself, and you'll see pretty quickly why the initial reaction from the pros, mathematicians, physicists, was just pure, unadulterated skepticism. And there it is. Yeah, at first glance, it just looks like a total mess, right? Like a patchwork quilt of physics. You've got this surface integral over here, a discrete summation there, and then what's this? This mysterious, lonely letter G. And the whole shebang is just set to equal 0. I mean, this does not look like anything you'd find in a standard textbook. No way. And this really gets to the heart of the immediate pushback. The critics, they were all over this. They pointed out, hey, there's no formal proof here. And that G term, man, that looked like the ultimate cheat code. Like a fudge factor you could just tweak to make the whole thing balance, no matter what the data said. If your numbers didn't add up, just blame G.
But, okay, let's hold on a second. If we resist that urge to just dismiss it as nonsense, and we actually look a little closer at the structure, we find something that's, it's actually pretty familiar. It's built on a really simple, super intuitive analogy that helps us get a handle on its two main parts.
And this is just a brilliant way to picture it. Okay, so imagine a giant bucket of water. That first part of the equation, the big integral, that's your global flow. Think of it like the hose filling the bucket and the drain emptying it out. Simple enough. Now that second part, the summation, that represents all the local events. All the little things happening inside the bucket. Sponges soaking up some water, maybe some straws sipping it out. All that internal action. So, here's the kicker. The crucial point is that this isn't some bizarre new kind of physics. It's actually just a conservation law in disguise. It's a restatement of a principle we already know and trust. I mean, think about it. Whether you're talking about water or energy or mass, it all has to be accounted for, right? The total change in any system is just what comes in and out at the edges, plus whatever gets added or removed inside. Nothing can just poof into existence or vanish into thin air.
Okay, so now let's get to the juicy part, the part that makes this equation so special, the bit that caused all that controversy, and honestly holds the deepest meaning of all, that mysterious G term.
So let's think this through. If the rest of the equation is basically just a super meticulous accountant tracking all the known flows across the boundary and all the known events happening inside, then what on earth is this leftover piece? What is G actually accounting for?
Well, it's not just an error term, that's for sure. It has a name. The Gödelian residue. And yeah, that's inspired by the legendary logician Kurt Gödel. His work basically proved that any formal system, even something as solid as math, will always have true statements that it can't prove about itself from within itself. So G becomes a placeholder for that fundamental limit. It represents the part of a system that can never be fully described by its own rules.
And this is where a purely conceptual piece of math takes a wild turn and becomes something profoundly real. This is the big reveal, folks. This is where G stops being some abstract idea and turns into maybe the most familiar thing in the entire universe. That G term, the Gödelian residue, it is the observer. It's you. It's me. It's the vantage point from which the system is being measured. It represents the simple, unavoidable fact that you can't describe a system without acknowledging that you are the one there describing it.
And this idea connects G directly to a cornerstone of modern physics, Heisenberg's observer effect. You've probably heard of it. In the quantum world, the very act of measuring something fundamentally changes it. You can't ever be a truly separate, neutral spectator. Well, G is basically the mathematical admission of that exact same principle. It says any model you build from inside a system will always have a blind spot, the effect of you, the observer, which you just can't measure from your own perspective.
Okay, so what do we do with an equation like this? One that's packed with philosophy, logic, and the observer? Well, it turns out it has a shockingly practical, down-to-earth application.
We're going to make this abstract concept totally concrete, and we'll do it by applying it to a system that's driven by something we all understand, greed, or, money. We're going to use this equation to find something that is, by its very nature, designed to be hidden from official view.
And check this out. This is how it works. It's brilliant. Those abstract terms, they map directly onto real-world economic stuff. That boundary integral, that's just the net flow of imports, exports, and capital across a country's borders. The discrete summation, that becomes big market shocks, like a massive bailout or a sudden crash. And that leftover, our old friend G, well, that becomes the shadow economy, all the hidden value, all the transactions that never, ever make it onto the official books.
So what this gives us is a surprisingly simple three-step process to quantify what we always thought was unquantifiable. Step 1, you measure all the official money flowing across the nation's border. Step 2, you add up all the big known market events happening inside the border. And step 3, you look at the difference between all that and the actual measured economic growth. And whatever's left over, yep, that's G.
And this has been used in the real world. In one example, accountants tallied up all the official flows and known events, and it came to $440 million in economic activity. But the actual measured GDP growth for that period was $500 million. So where'd the extra $60 million come from? Well, the equation revealed the leftover, that G, was a positive $60 million, a precise measurement of the shadow economy's contribution. Amazing!
And that really leaves us with a pretty provocative thought, doesn't it? We started this journey with a so-called toy equation, something that most people wrote off as complete nonsense. But by taking it seriously, we found a way to account for our own blind spots, for the observer, and use it to measure a hidden economy. So the big question is, what else is hiding out there in plain sight, just waiting for the right kind of equation to finally bring it into view?